What's up guys, my name is Edric Yao and welcome to the video. You probably clicked on this video because you don't want to read books about tessellations and would rather listen to someone explain it for you. Well, you've come to the right place. In this video we will be talking all about tessellations and we will be focusing on four main questions. First, what are tessellations? Second, what are examples of tessellations? Third, how are tessellations made? And lastly, how are tessellations used by engineers and architects, and how important is it? Don't forget to pay close attention. You're free to screenshot the slides and whatnot, take down notes to help you remember what will be said in this video. Well then, let's begin. Before all the complicated stuff, let's brush that out of the way and first define what are tessellations. According to the Merriam-Webster dictionary, tessellation is defined as a covering of an infinite geometric plane without gaps or overlaps by congruent plane figures of one type or few types. Well, this basically means tessellation is a plane full of repeating shapes which leaves no gaps and overlaps in between. Let me give you some examples of what tessellations look like. So here you have three examples of tessellations. You have the first figure, which is full of hexagons, the second figure full of squares, and the third figure full of triangles. I'm just showing you these examples, but you might be wondering, what makes these shapes tessellations? Now, the first thing we need to understand is that the interior angles around a vertex must add up to 360 degrees. Now, take the figures I showed you earlier. Let's look at the first figure. The first figure is made up of only hexagons, so let's enlarge it. So as you know, a hexagon is a polygon with 6 sides, and each interior angle in a hexagon is 120 degrees each. So here, the circles you see here are what you call the vertex. And the vertex is the point in which the angles of the polygon are right next to each other. So as you can see, around the vertex there are 3 interior angles of a hexagon. And as you know, each interior angle of a hexagon is 120 degrees. Since there are 3 sides surrounding the vertex, so doing basic math, 3 times 120 is equal to 360 degrees, fulfilling the condition we set earlier that each interior angle must add up to 360 degrees around the vertex. Now, taking a look back at the examples, now let's look at the second figure. The second figure is made up of only squares, and as you can see in the vertex is surrounded by 4 sides of a square. And as you know, a square has an interior angle of 90 degrees. And since there are 4 sides surrounding the vertex, and each side is 90 degrees, doing basic math, 4 times 90 is equal to 360 degrees, which also fulfills the condition we said earlier. Last, the third figure is the tessellation full of triangles. Taking a look at this, if you take a look at the vertex, around it, there are 6 sides of a triangle surrounding the vertex. And in this case, the triangles are equilateral triangles, meaning that each interior angle of the triangle is equal to 60 degrees each. So, if there are 6 sides of a triangle surrounding the vertex, and each side is 60 degrees, so 6 times 60 is equal to 360 degrees, still following the condition we said earlier, which makes these shapes tessellations. If you are unsure about the interior angles of a given polygon, use this formula to help you find the interior angle. A equals to 180 minus 360 over n, where A is the interior angle of the shape, and n is the number of sides of the shape. Another formula that's also good to know is used when you want to find what kind of polygons can make a tessellation. You can use this formula. Kn is equal to 360 over A or 2n over n minus 2. where Kn is the number of polygons needed. Now let's talk about the different types of tessellations that you might find. There are two types of tessellations that you might find. The first being regular tessellations. Regular tessellations are made up of only one kind of polygon. In the examples above, the first figure is made up of only hexagons, the second figure is made up of only squares, the third figure is made of only triangles. And I think you get the point. But the only polygons capable of becoming regular tessellations are hexagons, squares, and equilateral triangles. Now then, the other type of tessellation you will find is called a semi-regular tessellation. Semi-regular tessellations contain more than one kind of polygon. The arrangement of the polygon around the vertex must stay the same all throughout. Have this figure, for example. This tessellation contains 3 triangles and 2 squares. Each side of a square is 90 degrees and each side of a triangle is 60 degrees. Doing basic math, you get 180 degrees and 180 degrees. Adding those two together, you have 360 degrees, still fulfilling the condition we set earlier, saying that the interior angles around the vertex must add up to 360 degrees. And if you look at the way the polygons are shaped, it is shaped in such a way that it adds up to 360 degrees, which leaves no gaps and no overlaps in the tessellation itself. Another way to tell if a certain figure is a tessellation is through the polygon arrangement around the vertex. To prove that a certain figure is a tessellation, there is a certain rule that we follow. At a certain vertex point, we look at the polygon arrangement around the vertex. We count the polygons starting with the polygon with the least amount of sides, and then move clockwise. We have to compare two vertex points, and if they have the same arrangement, then this proves that this is a tessellation. Take a look at this example. The vertex is still the same, and just like I said, we start with the figure with the least amount of sides. In this case, we start with this triangle, labeled with the number 1. We count clockwise, so now the blue square is 2, the red triangle is 3, the red triangle is 4, and then this blue square is 5. So from this triangle, we count clockwise, so the arrangement will look like this: 3, 4, 3, 3, then 4. If we take a look at a second vertex point, we do the same thing. We count from the polygon with the least amount of sides and count clockwise. Here we also start in the red triangle, so 3, and then the blue square, 4, because it has 4 sides, 3, 3, then 4. The arrangement in the first vertex and the second vertex point are exactly the same, proving that this is a tessellation. But now we will be talking about the different ways to form tessellations using symmetry. A tessellation is created because we use symmetry. It's basically repeating the shape over and over again. And there are techniques in which we are able to create tessellations. And there are 4 techniques. The first technique is translation, the second is rotation, third is reflection, and last is glide reflection. So the first technique we will talk about are translations. Translation is very simple. You translate the figure a certain distance in any direction to fit the figure, leaving no gaps. So if you use a hexagon, you can either translate it up, down, left, or right. And if you keep doing that, you can create a tessellation with only hexagons. Now, onto the second technique. The second technique we will be talking about are rotations. You can rotate the figure any way you want it, as long as it fits with the kind of tessellation you want to make. It still has to follow the 360 degree rule though. So taking a look at these equilateral triangles, as you can see, they're rotated in different angles from each other. And if you combine them, you can end up with something like this. And if you take a look at each vertex point, it still adds up to 360 degrees, following the 360 degree rule, making this a tessellation. And then if you add multiple of these, you can make an even bigger tessellation. Now, the third technique we will be talking about are reflections. Reflections occur when there is a line called an axis that divides one into two separate and equal parts. The figures on each side must exactly reflect each other, and the distance from a point to a certain point must be the same on both sides. So using the triangles we used earlier, if you take a look at this, we put an axis line right in the middle of the figure, and after doing that, it separates them. The figure on the left side is an exact copy of the figure on the right side, making this a reflection. Now, the last technique we will talk about is the glide reflection. So, glide reflections are a translation and reflection combined, where the translation goes first and then the reflection. The best example for glide reflection are our footsteps. We walk on one side and then on the other side, and the opposite foot moves forward, which does both translating and reflecting. Now that you know the different techniques on how to make tessellations, onto our last question. How are these tessellations used by engineers and architects? Well, the thing is, you can see them almost everywhere. Take these for example. On the top right, you see a honeycomb. On the left, you can see a floor tile. And at the bottom, you can see a table. The honeycomb is a perfect example of finding tessellations in nature. If you look closely, you can see that the honeycomb also has a pattern. It is a tessellation composed of hexagons, making it a regular tessellation. Not only are they found in nature, they're found in the things architects and engineers make. If you take a look at the bathroom tiles on the left, you can tell that it's a regular tessellation made up of hexagons. And if you take a look at the table below, you can tell that it also has a pattern, making it tessellation. Now that we've learned all about tessellations today, the condition, the different types, and techniques on how to make tessellations, let me test you if you were really paying attention with a simple activity. There will be 3 questions in this test, so it is recommended that you do not rewind this video so you can test yourself. Now that this is out of the way, let us begin with the first question. So the first question is, identify which among the choices are an example of a regular and semi-regular tessellation. And here are the choices. Are you done answering? Well then, here are the answers. Now on to part 2. The question is, given a vertex in the tessellation, identify the angles around the vertex and the polygon arrangement around the vertex. So here's the figure you will use. The circle is the vertex given. And note that the triangles are 90, 45, 45 degree triangles. Are you ready? Well, here's the answer. Last is the third question. Identify which of these tessellations use translations, rotations, reflections, and guide reflections. And here are the figures. So the first technique we learned about are translations, so we'll start with that. The figure that uses translation are the black and white squares. Next figure, this is the rotation figure. The third figure, this is the reflection figure. Now last is the glidal reflection. Well then, congratulations I guess. You're now done with the video. You now know all about tessellations. You know the conditions to make them, you know the different types, you know how to make them. You're all good to go. Well then, thank you for watching. I hope you enjoyed. Leave a like if you did. Don't forget to subscribe, leave a comment, and as always, I hope you have a nice day.